Imagine the immense blackness of space suddenly illuminated by a fiery explosion. This was the scene in February 2009, nearly 800 kilometers above Earth. Picture this: two satellites, one American, the other Russian, hurtling towards each other at an astonishing speed. The American communications satellite Iridium 33 and the Russian reconnaissance satellite Kosmos 2251 collided with a force equivalent to about 10 tons of TNT. Now let's break that down. Imagine the force of 10 tons of TNT, a destructive power typically reserved for war zones, unleashed in the quiet, cold expanse of space. The resulting explosion was not just a spectacular light show, but a catastrophic event that left behind an enduring legacy of danger. In the aftermath of this cosmic collision, an estimated 100,000 fragments, each of a centimeter or more, were scattered into the void. These fragments, pieces of metal and technology, were left to orbit our planet, creating a cloud of high-speed debris. These aren't just harmless specks of dust, but high-velocity projectiles hurtling around the Earth at speeds up to 12 kilometers per second. This isn't a problem that will simply disappear either. These fragments, these remnants of a catastrophic collision, will continue to circle our planet for about 100 years. Each piece, no matter how small, poses a significant threat. They could damage or destroy other satellites, contribute to further collisions, and even pose a threat to manned space missions. This event served as a stark reminder of the dangers of space debris and the potential for disaster when we fail to manage our activities in space. The 2009 collision between Iridium 33 and Kosmos 2251 wasn't just a spectacular space event, it was a wake-up call. The remnants of this catastrophic event continue to orbit our planet, contributing significantly to the growing problem of space debris. It's a problem that we, as a global community, must address if we wish to continue exploring and benefiting from the boundless opportunities space offers. One of the immediate dangers posed by space debris is, quite simply, it falling back to Earth. You see, when objects in space have completed their missions or suffered a catastrophic failure, they don't just disappear. Instead, they can become a sort of ticking time bomb, orbiting the Earth until gravity eventually pulls them back down. Larger pieces of defunct satellites or broken rocket stages could survive the fiery ordeal of re-entry into our atmosphere. Now imagine this: a chunk of metal superheated and traveling at astronomical speeds, hurtling towards the ground. The damage it could cause to property is unpredictable, to say the least. And the potential for injury to people? Well, that's a chilling thought. The reality is that our planet is being circled by countless pieces of space junk, any one of which could pose a serious threat. The risk of falling debris is a clear and present danger that we must contend with. Another danger that may not immediately spring to mind is the risk posed to our air travel. Picture this: large chunks of space debris, remnants of defunct satellites or discarded rocket stages, plummeting towards Earth. These fragments, not quite burning up upon re-entry, could potentially penetrate our airspace. Now, imagine an unsuspecting aircraft cruising at 35,000 feet, suddenly coming face to face with a rogue piece of space junk. The consequences could be catastrophic, creating a serious threat to the safety of air traffic, not to mention the lives of passengers and crew on board. This scenario may sound like a plot from a science fiction movie, but with an estimated 100,000 pieces of space debris larger than a centimeter, it's a growing concern that can't be ignored. The skies above us are becoming increasingly hazardous due to space debris. Space debris not only poses a physical threat, but also an environmental one. You see, these remnants floating in our cosmos aren't just benign pieces of metal. Many carry toxic materials or dangerous fuels, remnants from their operational days, ticking time bombs waiting for re-entry. Now imagine these materials being released into Earth's atmosphere. There's a potential for significant environmental damage, especially if these fragments fall in populated areas or sensitive ecosystems. We're talking about the release of harmful substances, potentially poisoning our rivers, forests, even the air we breathe. The consequences could be catastrophic, affecting not just us, but the flora and fauna we share this planet with. The aftermath of such an event could take years, if not decades, to rectify and would require a colossal effort from humanity. The potential for environmental damage is yet another reason why we must address the issue of space debris. The impact of space debris is not limited to physical and environmental harm. Imagine a world where your daily commute is disrupted because the GPS can't provide accurate directions, or you miss an important business call due to a satellite communication failure. This may sound like a dystopian future, but it could be our reality if space debris continues to damage the satellites we rely on for communication, navigation, and weather forecasting. When these critical infrastructures falter, it's not just our daily routines that are disrupted. The economic repercussions can be severe. Consider the financial burden of replacing damaged satellites or restoring communication infrastructures. The knock-on effect of this could lead to production losses and business losses on a global scale. And it's not just big businesses that would suffer. Think of small business owners who depend on accurate weather forecasting for their trade, or rural communities that rely on satellite communication for vital services. The potential disruptions and economic impacts of space debris make it an issue that we cannot ignore. The dangers posed by space debris are real and varied. Today, we walked you through the aftermath of the spectacular collision in space back in 2009. We discussed the potential threats from falling debris, possible clashes with aircraft, and the potential for environmental damage. We also touched upon how space debris can disrupt our communication and navigation systems, affecting our daily lives, and the economic impact that could result from damaged satellites or communication infrastructures. Addressing the issue of space debris is of utmost importance. Measures such as developing technologies for active debris removal, improving space surveillance systems, and developing international guidelines to reduce debris are critical. Moreover, promoting sustainable practices within the space industry is paramount. It is vital that we take these risks seriously and take appropriate action to ensure the safety of Earth and its inhabitants.